Okay, welcome to section 1.9, which deals with real numbers, but their properties. And some of the properties of real numbers, we have the commutative and associative. So we're going to first talk about commutative property. Okay, so when you add, suppose you have two numbers, 5 and 3. If I add 5 plus 3, I get 8. But what if I add the 3 first, 3 plus 5, I also get 8. So the order doesn't really matter, right? It doesn't matter if I add them first or add the 5 first or the 3 first, because you still get 8 either way. What about multiplication? 5 times 3 is 15, and 3 times 5 is also 15. So again, the order does not matter for multiplication. So let's talk about the commutative property. So commutative property basically is that order does not matter. You can move the numbers around, you can commute them, and they still get the same value. So it's something that we've already been using. We've always been using it, but now we're actually talking about it. Okay, and the same thing works for multiplication. Okay, so what about subtraction? Do you think that subtraction, does order matter when we subtract numbers? So does 7 minus 3 give us the same result as 3 minus 7? So let's try it. So if you get 7 minus 3, you get positive 4. But 3 minus 7 is negative 4, so they do not work. So for subtraction, it does not work. Similarly, division is the same thing, because 12 divided by 4 is 3, but 4 divided by 12 is 1/3, and they're not equal. So we know that subtraction and division are not commutative. In other words, the order matters. Division are not commutative. Okay, they do not have the commutative property. Okay, order does matter. Okay, so addition or multiplication are commutative, and subtraction or division are not. Okay, so that's the takeaway. So let's do another example to introduce the associative property now. Notice that if I have 7 plus 8 plus 2, okay, I have these three numbers. If I add 7 and 8 together first and then the 2, I get 15 plus 2, 17. What if I add the 8 and the 2 first, which is 10, 7 plus 10, that's 17. So basically the ordering of adding equals the same. Usually, yeah, and I know before we've said, well, when you do PEMDAS, you go from left to right, right? But sometimes it's easier to order them differently or to commute them differently, okay? So, but we need to know when we can do it. We can only do that for addition and multiplication. So let's say we want to multiply 5 times 1/3 times 3. What if we multiply the first two and then multiply by the third? We would get 5. What if we did it the other way? 1/3 times 3 is 1. 5 times 1 is 5. So they both work. So associative is if you have changing the grouping, you can reorder them, not necessarily move them around. They're still in the same order. Notice A is first, B is second, C is third. There's the same order, except there's parentheses. These are regrouped. Okay, so you would do these two first, and on the right-hand side, you would do these two, but you'd get the same result. Okay, now let's do some examples. I think these first two examples are for the commutative property, and then we'll do some associative property. Okay, so just to note, so what is the commutative property of addition? So A plus B is equal to B plus A, meaning I can reorder it. So look, I have 18P, 15P, 6Q, and 5Q. So if I move these two around, I get 18P plus 15P plus 6Q plus 5Q, and then that's totally okay. So now it's easier to add like terms, right? So this would be 33P plus 11Q. Okay, so same thing here. So if we rewrote this, 23R plus 9R plus 14S plus 15S. Okay, so the first two would give us 32R plus, and then this would be 29S. Okay, now let's look at some examples of associativity. So if I regroup this here, so if I have here 5/13 plus, and I regroup the 3/4 and the 1/4, that's easier because 3 plus 1 is 4/4, right? So this would be 4/4 because it's already common denominator. So that's just equal to 1, okay? So it's 5/13 plus 1, which I can rewrite as 13/13. Or I can just write this as 1 and 5/13 because that's one way to do it. Or I could write 5/13 plus 13 over 13, which is 18 over 13. Okay, this is improper, but that's all right. Okay, so let's go ahead and do the next one. So again, I can use the associative property here. I can group together 5/8 and 3/8, and I get the same thing. This is 8 over 8, which is 1. Okay, plus 7 over 15. This is equal to 1. So we can write this as 1 and 7/15, or we could write this as 7/15 plus 15 over 15. Remember, 1 could be any number over itself, which is 22 over 15. Okay. So let's go ahead and do 6 times 3x. If I want to rewrite this, I would just do it. Sometimes we just do associative property mentally, you know, so this would be 18x. And then here, 8 times 4x, we would just multiply the numbers first, and you would get 32x. Okay. Let's continue. So that would be... we just did that one, 32x. Okay, so here it says use the identity and inverse properties of addition and multiplication. So first let's talk about what that is. Okay, so for the real numbers, you have what's called an identity. So what the heck is an identity? It's a number that, it's kind of like a universal unit, like the number 0 for addition and for multiplication. You have two types. The additive identity would be 0. Because anything that you add 0 to is still itself. It remains the same. And so the identity property of addition would be any number plus 0 is equal to itself. And 0 plus that number is also equal to that number. So 13 plus 0 is 13. Negative 14 plus 0 is 14. 0 plus negative 8 is negative 8. So you see what I mean? 0 doesn't do, adding the identity doesn't do anything. But now we have the multiplicative identity. So that's 1. Because if you times any number by 1 or 1 times any number, you get the same number back, okay? So that's the identity property of multiplication. Okay, so 0 is the additive identity because it has to do with adding, and 1 is the multiplicative identity. Okay, so what number to 5? Added to 5 gives us 0. So if we add negative 5 to 5, we get 0. And if we add positive 6 to negative 6, we get 0. So notice that it's the opposite. Okay, the missing number was the opposite of the number. Okay, so that's called an additive inverse. Okay, so for any number A, its opposite is the additive inverse because a number and its opposite add to 0. Okay, now the multiplicative inverse would be something that gives you the identity back, the multiplicative identity. Remember that that's 1. So any number times its reciprocal is equal to 1. Okay, so the additive inverse of 5/8 is going to be negative 5/8. It's just the opposite. Additive inverse of 0.6 will be negative 0.6. Additive inverse of a negative 8 is positive 8. And additive inverse of a negative 4/3 will be a positive 4/3. So notice that it's the opposite. So the signs change. Okay, so let's go ahead and do a couple more. What's the additive inverse of 7/9? Well, that's just negative 7/9. That's its opposite. What about 1.2? Positive. The additive inverse will be negative, the opposite. What about the additive inverse of negative 14? Well, that's just positive 14. And then what's the additive inverse of negative 9/4? That's positive 9/4. Okay, not too bad. Now, multiplicative inverse, that just means the reciprocal. Okay, so, you know, the reciprocal, when you multiply a number by its reciprocal, you get back to 1. So that's what I want. So what's the multiplicative inverse, aka the reciprocal of 9? Well, that's just 1/9. Okay, what about B, negative 1/9? Well, the reciprocal of that, the multiplicative inverse, is going to be its reciprocal, so negative 9 over 1, or just negative 9. So C, you have 9/10, which is 9 over 10. What's the multiplicative inverse? The multiplicative inverse is going to be 10 over 9. Okay. All right, let's talk about 0 for a second in terms of dividing or multiplying. Okay, So for any real number times the product of any number, real number, and 0 is 0. So that 0 is very powerful, right? However, you cannot really divide by 0. 0 divided by anything is still 0. And 0 divided by a number is 0, right? Anything. 0 divided by any number gives you 0 back, right? But that's division of 0. But division by 0 means that if you can't divide a number by 0, okay? So if you divide a number by 0, that's actually undefined, okay? So any number divided by 0 is undefined. So if we're dividing by 0, it's undefined. And if we're dividing into 0, right, or dividing 0, that's 0. Okay, so let's look at that again. So this is just the same thing we just said. Okay, so 0 divided by anything is 0, but anything divided by 0 is undefined. So let's see here. Let's do that. So A, negative 8 times 0, that's just going to be 0 because the product of anything with 0 is going to be 0. How about B, 0 divided by negative 2? Well, that's just 0 also. And then C, negative 32 divided by 0. Well, you can't divide by 0. So that's, undefined. Okay, let's do some super fun examples. Okay, so for A, 0 divided by anything is just 0 because it's in the numerator. B, 0 is in the denominator, so it's undefined. Okay, how about here? Anything multiplied by 0. So negative 14 times 0 is 0. B, 0 divided by anything is 0. And then C, undefined. We cannot divide by 0. Okay, it's really important. So let's look at this now. Look, let's simplify this problem. So here we notice that these are additive inverses of each other. So if I was to write this in a different way, okay, these two become 0. 0 minus 73n gives me just a negative 73n. Okay. All right. So we can continue to distribute. Let's go ahead and do some more problems. These problems, the reciprocals become 1. So then you just get 8 over 23. If you want to see it close, you can move it around if you want to. So you could rewritten this way, and this becomes 1. Okay, so same thing here. This number times its reciprocal is 1, so your answer is just 11 over 25. Okay, again, this one is 0 divided by whatever, who cares, n plus 7, that's still 0. B, any number, 18 minus 60 divided by 0 is going to be undefined. Okay, and then here, 3/4 times 4/3, this is the reciprocal, so that's 1. So your answer is just 6x plus 12. Okay, let's talk about the distributive property for a quick second. Okay, so what's very cool about the distributive property is if you have real numbers, A, B, and C, or variable, which can represent a real number, right? When you multiply a quantity with the number in front of it, what are you saying? You're saying do this that many times, okay? So this is the equivalent of writing, distributing this A. Okay, so that would be A times the first term plus A times the second term. Okay, so it also works on the right-hand side, and it also works for subtraction, left and right. So this is best just illustrated by doing a problem. 3 times the quantity x plus 4 would give me 3x plus and then 3 times 4. So notice that I distributed the 3 on the outside. So this is 3x plus 12. Okay, so how about here? 4 times the quantity x plus 2, that gives me 4x plus 8 because 4 times 2 is 8. Okay, let's continue here. I draw these arrows to help. So 8 times, so 8 over 1 times 3/8 x plus 8 times 1 over 4. This is over 1. So these 8s will cancel. We get 3x over 1, so that's just 3x. Here, 4 goes into 8 twice. 2 times 1 is 2, and that's it. Okay, let's go ahead and distribute the 100. 100 times 0.3 would give me, remember, 2 decimal places. That's 30 plus, and then this will move just 25q because of the 100. Let's do -2. -2 times 4y, I'll write it out, minus plus a -2 times 1. So this is just going to be negative 8y plus a negative 2, so that's just negative 2. Okay, or minus 2. Now, if I don't have anything here, it's just the minus sign. It's assumed to be a 1. Okay, so negative 1 times y is just negative y. And then a negative 1 times a positive 5 is negative 5. Okay, let's do a few more. Okay, so here, let's distribute the negative 2. So we have 8 minus 2x minus 6, combine like terms. 8 minus 6 is 2 minus 2x. Okay, let's do this. We have 7x minus, and then we have negative 5 times x is negative 5x. And then move this negative 5 times a positive 4 minus 20. Like terms, 2x minus 20. Okay, let's continue here. We have 4. We distribute the 4, then we distribute this negative. So we get 4x minus 32 minus x minus 3. 4x minus x is 3x. Negative 32 minus 3 is negative 35. And then we have here 8x minus 1, 8x minus 8. Then we have negative x minus 5. So like terms, 8x minus x is 7x. Negative 8 minus 5. Okay, same signs. You add 13, negative 13. Okay, so just to recap what we've done, we went over commutative property of addition, of multiplication, associative property, which is regrouping, distributive property, and then the identity property of 0, which is the additive identity, and then of multiplication is 1, okay? And then again, the inverse property, that means that any number added to its opposite is going to give you 0, and then the inverse property, any number multiplied by its reciprocal will give you 1. And then we went over properties of 0, that if you multiply anything by 0, you get 0. If you divide into 0, you get 0, but you cannot divide by 0. That would be undefined. Okay, that is it. So your super fun homework, 7:23 to 8:15 odds. Okay, so make sure you practice this. Okay, and good luck. That's the end of the chapter. Yay, jazz hands. Pat yourself on the back and happy studying. I will see you in the next video.